Okay, so welcome back for the third lecture of this week. So in the last lecture, we talked about what are the various variations or validations that you might be using in general. Okay, so today we will now talk about very standard algorithm for doing spelling correction. So in general, when I talk about spelling correction, I might be talking about isolated word error detection or correction, that is a word without the context. Even there, it might be a word that is in my vocabulary or not in my vocabulary. Okay, so we will see examples for that. Or I might talk about doing correction in the context. There again, the word might be in the vocabulary or out of the vocabulary. And we will see how the simple approach of noise channel model can be applied for doing spelling correction. Okay. Now, what is my noise channel model? So if you think of the model name, what is happening? You are having an observation X, that is a word that is misspelled, and you want to correct it. That is your observation. But what is the idea of this model? So whenever you have a misspelling, you wanted to write a correct word, okay, and you went through a channel that can be your keyboard or something else, and that's how your word got misspelled. So that is what you are assuming. You have a correct word W, okay, this is your correct word, and you have an incorrect word X, that is your observation. Yes, now you wanted to type this correct word W, but you went through a channel, and this we are saying is a noisy channel, and you are making some mistake while going through this channel, and the word that you are observing is X but not W. Now your observation is X. Now given this observation X, how do I find out what is my most likely candidate for W? What is my W? Okay, so in general, how can I try to approach this problem? I am seeing a word X that I know is misspelled. Now how do I know it is misspelled? One crude way of doing that is I maintain a dictionary that is my set of all the words in my vocabulary, and if the word X does not match with any of these words, I say this might be a misspelled word. Okay. Now once I know X is a misspelled word, that means I have to correct it. Now I will have to first start with what are all the possible candidates for correction. So suppose one simple way could be I find out all the words within a distance of something. Okay. Now among those, which one is the most likely candidate? Okay. So in terms of noise channel model, what is the W from which X has been written? So misspelled, and we wrote X. So in terms of noise channel model, I want to find out W hat that gives me the maximum probability PW given X among all the possible words in my vocabulary, or it can be in my set of candidates. What is the word that gives me the maximum value for PW given X? Now, how do I compute this probability PW given X? You see, as per the noise channel model, I first started with the word W, and then I went to the channel and I ended up with the word X. So I can only find out using my channel what is the probability of X given W. Okay, I will have to somehow use it to find out probability of W given X. Yes, so what is a particular theorem in probability that you can use for this? So remember Bayes' theorem. So I want to find out probability W given X, but I only can find out from my channel probability of X given W. So how do I write PWX in this term? So I say this will be P X given W, PW divided by PX. Yes, so I can replace it by argmax of this. Now what is your variable here? Your variable is W. You can have multiple different words, but your X remains the same for each individual word. So what in fact you are trying to do, for each word you are computing this value and then you are seeing what is the maximum value, which word gives you the maximum value. Now, among the 3 different probabilities that you are using for this formula, which one you might remove for this computation? You see, the probability px remains the constant across all the words, so it will not matter to my decision of which one is having the highest probability, because this will simply depend on this particular multiplication. So I can as well remove px and keep my argument, okay, and that's how we actually use. Okay, so I write it like that, and I remove the probability px, and that's how I will find out which one is the correct word w for x, which one gives me the maximum probability for probability x given w times probability w. So now we will see how do we compute these probabilities individually. What are the various ways we can compute these probabilities? Okay. So we are talking about non-word spelling errors. So again, what do I mean by non-word spelling errors? A word that is not in the dictionary or my vocabulary, and I know, okay, this might be misspelled word. Suppose I have taken the word here actress. Okay, so actress is not in the dictionary. It can be actress, across, or whatever, but we do not know. So this is the observation that we made. Now using noise channel model, I want to find out what should have been the correct word. Okay. So now the first thing I will need to do, I will need to find out what are the candidate words that might be correct. Okay. So how do I find the candidate words? I'll try to find out the words that are having similar spellings, that are having small added distances. Okay. Or I might try to use the words that are having similar pronunciation. So both of these are possible. So then I make some sort of candidate set. So suppose I have 10 different words that might have given to actress. So these are my various candidates for W, and I need to use the noise channel model to find out which one is the most likely candidate. So, and suppose I am using my DL added distance. Okay, this is a small variation of my Levenstein added distance. Remember Levenstein added distance, what were the operations? We had insertion, deletion, and substitution. In this particular added distance, we also have the transposition. Okay, so insertion, deletion, substitution, and transposition of 2 adjacent characters. So we discussed about how to modify our dynamic programming algorithm to take into account of this transposition in the last lecture. So now, so given two strings, I can always find out what is the word. So given a string, I can find out what are the other words that come within additions of 1 or 2. Okay, so suppose I start with actress, that is my observation, incorrect word. I try to find out what are the all possible candidates that come within additions of 1. Okay, so here is the word actress. Now I find the words like actress, cress, caress, access, across, acres, and acres occurs twice in this list. Why? And we will see that. Let us try to understand the first candidate word, actress. So what else we have written here? So we have written, so this is my correct word, this is my incorrect word. So what change did I make for going from correct word to incorrect word? So I had a letter T in my correct word, but I replaced it with null. So this is in deletion. I deleted a T from my correct word. So that's why this is deletion. Okay. Similarly, how do I go from crash to actress? I have to insert A. So this is again insertion. Yes. Similarly, how do I go from caress to actress? I am doing a transpose. So CA change to AC, transposition. Access to actress, C got changed to R. Across to actress, O got changed to E. Now, so why there were 2 acres? You see, acres to actress, I can go by doing one insertion. But this insertion can happen at 2 points. It can happen either here or it can happen here, and these two will have different probabilities. Okay, remember the probability of substitution will depend on what is the previous word, what is the previous character in this word. Okay, so they will have different probabilities. That's why they are two different instances. Okay. Now, so that means whenever I have a misspelled word, I have to first generate all the possible candidates. Okay. So there we try to use some sort of statistics. How many different candidates should I be using? So the general statistic says that 80% of the errors are within a distance of 1, and nearly all the errors are within a distance of 2. So that means I can mostly try to use the candidates within a distance of 1 or 2. Okay, maybe 1 will do for most of the cases. So that's what we did in the previous example. Starting from across, we found out all the candidates within a distance of 1. And while generating the candidates, I might also allow for deletion of space and hyphen. So if I have a word like this idea without a space, I might allow this idea with a space. And similarly for hyphens, in-law to in-law with a hyphen. So now when we are trying to compute the probabilities, we had two different terms, probability of x given w and probability of w. So we will first see how do we compute probability of x given w. Now suppose we are taking the simple case where there are only one added operation from the input string, or the correct word to the incorrect word. So what do I mean by probability of x given w? I would mean what is the probability of that added operation being done. So remember we had 4 operations: insertion, deletion, substitution and transposition. So I need to define probabilities for each of these. So here that's what we are defining. We are defining deletion over xy. What do I mean by that? Whenever in the input string or input word I had the sequence xy, this is my correct, and it got typed as x, this is my incorrect. So xy got typed as x. So this is I have deleted y. So this will depend on the previous character x in this string. Similarly, what happens in insertion? I had x in the correct and I inserted y in the incorrect. So this is the case of insertion. Substitution, x got typed as y. So I had x in my correct string, it got typed as y in my incorrect string. And what is transposition? Again, xy here incorrect got typed as yx in my incorrect. So these are the 4 different possibilities if I am having only one added operation between the 2 strings. So now the question is, how do I find out probability of a particular deletion or insertion operation? So let us take one of these and see how we will actually find out these probabilities. So let us take the simple case of deletion. So how do I find the probability that in a string a set of characters xy, a character bigram, I can also say it as a character bigram, got converted to only x. So how will you find out this probability? So we will have to see in general in corpus how likely is this error. So now what kind of data do I need to count to find this probability? So I need some sort of data where users have written some text and they have made some mistakes, not knowingly. Okay, so they have made some mistakes that in general people do, and somebody has then seen this corpus and tried to correct it. Okay, so suppose I have a corpus that is corpus, this is a real corpus, and that contains various errors, and then I also have a corrected corpus. Now, how will I use these 2 different corpora to find out the probability of deletion xy? I will say how many times do I see in my corrected corpus a word containing the bigram xy for which the corresponding word in my actual real corpus had only x. That means actually the word should have been having xy, but it was written as x. So now how will I compute the probability? I will see in my real corpus how many times I have this character bigram xy, and out of those how many times y was deleted in my real corpus, and that will give me the probability that after x what is the probability that y is deleted. So whenever how many times xy occurred together, out of those how many cases y was deleted. And similarly I will find it out for all cases of insertion, substitution and transposition. So let us see the actual matrices. Okay, so you are seeing here insertion, deletion are conditioned on the previous character. Okay, so that's how I find out the probability of x given w. X is my incorrect word and w is my possible candidate for correction. So remember how we found out deletion? We said how many times this character bigram wi minus 1 and wi occur in my corrected corpus, and among those how many times wi was deleted after wi minus 1. Okay. Similarly here insertion, how many times the word wi minus 1 occurs in my corpus, and among those how many times I inserted xi in my real corpus where people made mistakes, how many times they actually inserted xi after wi. Okay, wi minus 1. Similarly substitution, how many times wi occurs in my corpus, among those how many times it was substituted with xi. Same thing you will do for transposition, how many times these two characters occur together, among those what fraction of times they were transposed. So that means you need two corpus, one where people have made mistakes, another the same corpus that has been corrected. Okay, and then you can compute all these probabilities. Now if you go back to the previous example of finding various candidates for accuracy, so we had 7 different candidates here. Now we already saw what is the correct and error word, and we are using the model we saw in the previous slide to find out probability of x given word. Okay, this one. So now first we are writing what is my x given w. So whenever this was my deletion, from actress t got delete and we got actress. So how did we find the probability of deletion? We said what is the probability that among all the times that the sequence ct occurs, what is the probability that t gets deleted? So out of ct I see only c in my corpus, and this probability I find my corpus to be 0.000117. Okay. Similarly insertion, that means a got inserted in the beginning of the string. Transposition, AC in place of CA, and so on. And so here you see there are 2 different ways you can do insertion, after E or after S. That's why you have 2 different probability values also. Okay. So again from the corpus you will find all these probability values, probability of x given my word, for different words. What is probability x given word? Now what is the other probability you have to compute? Probability of w itself. So what is the condition? As such, you will try to favor a word that is more likely to occur in the corpus than a word that is not so likely in the corpus. Okay. So suppose I use a corpus and I also find out the probability of the word. Okay. So now I have found out probability of x given word and the probability of the word, both of these. So remember my noisy channel model, I have to multiply these probabilities and find out which of the candidate gives me the highest probability value. So suppose I do the same. So in this slide you will see, so I am multiplying these two probabilities, and we are putting 10 to the power 9 just so that we are able to see these numbers. Okay, otherwise they might be 0.000 to the point that we will not be able to compare them. So the first probability is 2.7 times 10 to the power 9 minus 9. Sorry. So what are the two candidates that have the highest probability? You see here I have actress and I have across. So these are two words that are having the highest probability. And in general you might write across as the correct candidate. Okay. So now remember we were saying we can do it without using the context or with the context. So without using the context, this is the best you can do. And suppose they come out to be really close, 2.7, 2.71. Without using the context, you cannot find out which is a better candidate than the other. But suppose you are allowed to use the context. So can you do better? Okay. So let us see for the same spelling correction. If I have the context, what will I do? So suppose my sentence says versatile across huge. Okay, and I have to correct it. And remember what are the two candidates? The two candidates are actress and across. So the two sentences are versatile across actress huge, versatile across huge. Now which one is more likely? Okay. Now how do I find out? How do I use the fact that probably versatile actress or actress huge is more common than versatile across and across huge? So for that, what we can do, we take some corpus. So this is some corpus from contemporary American English, and we use some smoothing. So do not worry about what I mean by smoothing. We will cover that in detail in language modeling. So suppose I do some smoothing. So idea is that we try to find out the probabilities of a word coming after another word. That's what we are doing. And from there, I find out these probabilities that the word actress occurs after versatile is 0.000021, and the probability that the word across occurs after versatile is the same. And that makes sense also. Versatile across many different fields and versatile actress, they might have the same sort of probability of occurrence in the corpus. Now what about the other bigram? What about the other two word combination? That is actress huge and across huge. So we see in the corpus, we find actress huge has a much higher probability than across huge. Okay, and if we have this information, we can use that to refine the probabilities further. So suppose I simply multiply these two probabilities with my earlier counts. So what will I get? So I'll say probability of versatile actress huge is the two probabilities 210 times 10 to the minus 10, and probability of versatile across huge will be 1 times 10 to the minus 10. So this gives me that versatile actress huge is much more likely than versatile across huge as per my corpus if I am using the context. And this can further help me to find out what is the correct word that should have been there in place of actress. Okay. So now the next concept is the real word spelling errors. So what do I mean by that? There might be errors where the misspelled word is actually in my dictionary. Okay. So like you see the sentence here, the study was conducted mainly by John Black, and we know the correct word should have been by, but the user ended up typing B. Now just think for a moment. Can I solve this problem without using the context? So without using the context, how can I even say that it should be by and not be? Okay, I might use the individual probability of a word occurrence, but that is not a good method to say that. So in that case, I might find errors everywhere in my corpus. So I should be try to using my context in some way. Okay, same in the next sentence, the design and construction of the system, and I know this should be and, but the user ended up typing and. Now these are real words in my vocabulary, and I want to correct the spellings. One thing is sure, I should be using the context. Now how do I actually use the context for trying to correct these errors? Okay, and this is again some statistics that 25 to 40% of the spelling errors that we see are real words. Okay, so now suppose I have a sentence X that contains words W1 to Wn. Now we do not know which of these words is in error. Okay, because all of these are real words in my dictionary. So how do I actually start doing the spell correction? So what I will do, for each of the individual word, I will try to find out what are the possible candidates that might be the correct words. Okay, and there I should not forget to include this word itself, because this might be a correct word also. So here what we are doing, for the word W1, we are saying okay, candidates are W1 or some word W1 prime, W1 double prime, W1 triple prime, and so on. They are possible candidates for correction. W2 again, the word W2 and other candidates, same with W3. Now what is my problem? Now I can have any sequence. From the candidates of W1 I can choose any one, W2 I can choose any one, and so on. And among all these possible sequences, I have to find out which one is giving me the highest probability in some sense. Okay. So I want to find the sequence W that maximizes the probability of W given X. Okay, that is whether this would be a good sequence, or this would be a good sequence, or this would be a good sequence, and so on. Which of these sequence will be the best in this case? So again, we have to find out W that maximizes probability of W given X. So again, can we try to use the noise channel model? So we will see. Okay. So now we are taking a real example here, 2 of view, and probably it should have been 2 of the, and we are not seeing the other words right now. So as per my model, what I will do, I'll take the word 2, I'll put this word along with all the other possible candidates. So I have put TOO, TAO, TU, all are having a smaller distance. Similarly with of, I am putting ON, OFF. With the due, I have put due, through, the, and so on. And we know the correct sequence is 2 of the. Fine. But in general, suppose I have to find out the probability for each sequence. This might become exponential. So you can do the simple math. Suppose each word on an average has 4 possible candidates, including itself. And there are 5 different words in my sentence. So how many different sequences I will have? 4 to the power 5. Okay. And if the number of words increase in my sentence, this will keep on increasing. So now, to avoid this problem, we try to use some sort of, we make some assumption that is also a simplification to the model. What is that? We say, okay, let us assume that there will be at most one error in the sentence. Okay. So how does that help? It helps in that whenever I am choosing the candidates, I will only choose a different word for one of the words. So what do I mean by that? Suppose I had my sentence W1, W2, W3, and this has some other possible things like W2 prime, W2 double prime. This has W1 double prime, W1 double prime, and this has W3 prime, W3 double prime. So in the previous model, we would have taken all the 3 cube, that is 27 different candidates in the previous one. So with this assumption, what we will do, for W1, if I am choosing a candidate W1 prime, I'll assume W2 and W3 were correct. Okay. So this is the assumption. There might be at most one error per sentence. So how many candidates will be there? I'll have 2 possibilities here, 2 possibilities here, and 2 possibilities here. Okay. So there would be at most 6 plus 1 if you are taking the one where the original sentence might have been correct. So W1, W2, W3 as it is. Okay. So the candidates are W1 prime, W2, W3. Only one error per sentence. W1 double prime, W2, W3, and so on. So this hugely reduces the number of candidates for which I have to check. And this is quite true also in practice, that you do not make more than one error per sentence in general. Okay. So Now, once we have this assumption, we want to find the sequence W that maximizes the probability of W given X. So I can again try to use my noisy channel model. How? Find out the sequence W hat that maximizes the probability of P W given X. X is my observed sequence and W is one of my candidate sequences. And we know how to find out the candidate sequences. So that is for each of these sequences W, I have to find out the probability W given X. Now, as per the noisy channel model, how will I write it down? So I'll again use the Bayes theorem here because I am starting from W and going to X. So I can only find the probability of X given W. So this is what I will do. Okay. Now how do I write probability X given W? X is a sequence, W is a sequence. So suppose they have the same number of words, I can make a simplifying assumption that Px given W is simply multiplication of probability of individual word given that in the sequence. Okay. So suppose my word is, this is my W and this is my X. So probability X given W, I write as probability of W1 prime given W1, probability W2 given W2, probability W3 given W3. Okay. So now there are two kinds of probabilities here. One is when the two words are not the same, probability of doing an error. Yes. One, they are the same. Now how do I find out the individual probabilities? This one we have already seen. In the previous case, I will find out what are the added operation and what is the corresponding probability, if it is deletion, insertion and so on. So this is same as the previous case, same as in previous. But how do I find out the probability of W2 given W2? Should it be 1? Now it will depend on what is the kind of errors that you are seeing in your corpus. If you are seeing that there are on an average 1 error per 10 words, you will say this probability is 0.9. This is what is correct. This is the probability of that the word is correct. If there are 1 error in 100 words, you will say this probability is 0.99, and that's how you will fix this probability. Okay. So Px given W is same as non-word spelling correction, but we also need this probability W given W, and that is the probability that you have correctly typed a word, and that you can find by the kind of the amount of errors that you are seeing in your source. If there is 1 error per 10 words, you will say this probability is 0.9. If there is 1 error per 100 words, you will say this probability is 0.99. That's how you will set all these probabilities, and you will choose the candidate X that gives the maximum probability. Okay. Candidate W. Sorry. Now the other part is finding out probability W. Okay. By W I mean the sequence W1 prime, W2, W3. How do I define the probability of the sequence W? Okay. For that, we will use a technique called language modeling. So that will give me the probability of any such sequence of words. And we will use any of these unigram model, bigram model, or any other model for finding out this probability W. So this will be the topic for the next lecture. So in this lecture we discussed what are non-word errors, real word errors, how do we use noisy channel model to correct those. But there we also need something like probability of the sentence as such, probability of the sequence of words W. How do we obtain that? And that's where we will go to the idea of language modeling in the next lecture.